Ever wondered how we communicate with computers? How do we instruct them to perform tasks, solve complex problems, or even create stunning visual effects in games and movies? Well, the secret lies in a concept called programming languages. Imagine a world where everyone speaks a different language. There's no universal language, and people can only understand the language they've been taught. Now consider computers as citizens of this world. Each computer speaks its own language, known as machine language, which consists of ones and zeros. However, for humans, communicating in machine language would be a tedious and complex task, akin to trying to write a letter using only Morse code. That's where programming languages come in. Programming languages are like bridges, connecting the world of humans and the world of computers. They allow us to write instructions in a form that both we and computers can understand, just like how a bilingual person can translate Spanish to English, enabling two people who speak different languages to communicate. Imagine writing a recipe for a cake. The recipe is a set of instructions that tells someone how to make the cake, including the ingredients needed and the steps to follow. In this analogy, the recipe is like a program. The person baking the cake is like a computer, and the language the recipe is written in is like a programming language. Just as there are many languages in the world, there are many programming languages as well. Each one has its own rules and syntax, much like each language has its own grammar and vocabulary. Some languages are better suited for certain tasks than others, just as you might choose to write a love poem in French rather than German because of the former's reputation for romance. Output. In summary, programming languages are the tools we use to communicate with computers. They allow us to write instructions in a way that we understand, which can then be translated into a form that computers can understand. Different programming languages have different strengths and weaknesses, and programmers often learn multiple languages to be able to tackle a wide range of problems. Just like learning any language, mastering a programming language takes time and practice. But once you do, you'll be able to create amazing things, from websites and mobile apps to video games and artificial intelligence systems. So the next time you use a piece of software, take a moment to appreciate the programming languages that made it possible.